you need your Unit 2 note packet out. If you did not get a Unit 2 note packet, there is a digital one linked in Schoology. If you are not able to print off the note sheet for today, which is titled Divisibility and GCF, then simply take your notes on a sheet of paper and you can add it to your packet when you get here at school. If you're a distance learner and you did not pick up a math packet and you would like to, they are here ready for you. Just send me an email and let me know. Any way, shape, or form, you're going to take notes today. So if you have your packet, use it. If you don't, do it on a sheet of paper, or you can print off the notes from Schoology in the Unit 2 folder. Open up your note packet, or if you don't have a note packet yet, follow along with what is on your screen. You'll see your scale on the first page there. Our standard is I can read, write, represent, identify, and compare rational numbers. Minnesota says, hey, 7th graders, we got to be able to do that. Our goal for today to help us do that, to help us become a real number system master, is I can use the properties of divisibility to find factors of numbers. Underline divisibility and underline factors. Those are two words that you have heard many a times. However, they can easily be forgotten. So let's take a moment to remind ourselves of what they mean. You don't need to write anything down right now. Factors, remember, factors are few. They are the numbers we multiply together to get a product. Example, if I want to find the factors of 10, 10 is what I want to get when I multiply two numbers together. So 1 times 10 gives me 10, therefore 1 and 10 are factors. 2 times 5 gives me 10, therefore 2 and 5 are factors. Those are all the factors of 10, so I would say 10 has 4 factors. Divisible by means when you take a number and you divide it by another number, the result is a whole number, meaning you don't have a remainder. Divisibility rules are a way to test if one number is divisible by another without having to use a calculator or without having to do much calculating at all. So we are going to remind ourselves of the divisibility rules for the following numbers: 2, 3, 4, 5, 6, 9, and 10. Find note sheet 2.1 titled Divisibility and GCF. I'm going to have you pause the video and I'm going to have you write down the divisibility rule for the numbers shown and the examples. The examples are in purple. I'll get you started here. The divisibility rule for 2, you're going to write this: the number is an even number. It ends with a 0, 2, 4, 6, or 8. So if a number is an even number, that means 2 goes into it without a remainder. Therefore, the number would be divisible by 2. Here are 2 examples. 128, notice the last digit there. It makes 128 an even number because it's an even digit. So yes, 2 goes into that. Look at the second example, 129. 129 is not an even number because it doesn't end with a 0, 2, 4, 6, or 8. Therefore, when you take 129 and divide it by 2, you're going to get a remainder. Go ahead and finish filling in the divisibility rules for 3, 4, and 5. So you'll pause the video and then come back and we'll get the divisibility rule for 6, 9, and 10. Our final 3 numbers here, go ahead and write down the divisibility rule and the examples for each. Pause the video. So you have the divisibility rules down for the numbers that are on your note sheet. Remember, divisibility rules are just a quick way to test to see if a number is a factor of another. If a number goes into another number and gives you a whole number. I'm saying, how many times can I say the word number, right? I want to clarify 3 rules because these are the rules that we tend to struggle with the most. The rule for 3, remember, you add up the digits. So here's my number. You don't need to write this down. Just look at it with me. 99,996. If I add up these digits, I'm going to get 9 plus 9 plus 9 plus 9 plus 6. Digits make up numbers, right? The only digits we have in our number system are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ms. Kluwer, why didn't you say 10? Because 1 and 0, those 2 digits make the number 10. So digits means you take each piece of the number and you add it together. 9 plus 9 is 18, plus 9 is 27, plus 9 is 36, plus 6 is 42. 2. And you might go, well, I don't know if 3 goes into 42. That's still a big number for me to figure out. What you can do is do it again. Take these 2 digits, 4 plus 2, they give me 6. Is 6 a multiple of 3? Then we have divisibility, right? We know that 6 divided by 3 is 2. So therefore, 3 goes into this number. Do you see how when we broke apart the digits and found the sum, it wasn't helpful the first time around? So here's a reminder that you can take this and break it apart again. Go to the rule for 6. The one that we struggle with here is remembering that it has to be divisible by both 2 and 3. It can't just be divisible by 1. It has to be divisible by both. So the divisibility rule for 2 is it has to be an even number. So it ends with a 0, 2, 4, 6, or 8. Does this one end with an even digit? Yes, it does. So it's an even number. It's divisible by 2. 2 works. I'm going to put a 2 over there. The divisibility rule for 3, we just practiced that. It's where you take the digits that make the number and you add them together. So 5 plus 4 plus 0. 5 plus 4 is 9, plus 0 is 9. Can 3 go into 9? Or is 9 a multiple of 3? That's another way to say it. Yes, then we have divisibility. Since 2 and 3 pass for 540, that means this number is divisible by 6. And if you think about it, it's been a long time since you've heard this word. Prime factorization, tree. The prime factorization for 6 is 2 times 3. So that's why this divisibility rule works. One final one. The rule for 9. Quick little insightful piece for you to help you remember. It's really similar to the rule for 3, except this time you want to make sure that when you add up the digits that it's a multiple of 9 or that 9 goes into that. And remember, if you need to break it apart more because you're not sure if the number that you get 9 goes into that, giving you a whole number, break it apart again. Okay? So 9 and 3 are very similar. And if you think about it, the prime factorization for 9 is 3 times 3, right? So that's why these rules are so similar. Flip to the next page in your note sheet. We are now going to take a moment to review greatest common factor, which is what the acronym GCF stands for. And that is why we just practice our divisibility rules, because in order to find greatest common factor, we have to determine if a number is a factor of another. And divisibility rules help us do that. Go ahead and pause the video here, and I'd like you to get your GCF chart organized how you see mine on the screen. When you're ready, click play, and we'll review GCF together. All right, let's get to the next part of this lesson, which is focusing on the greatest common factor. So we just talked about divisibility rules, and they help us really quickly determine if a number is a factor of another. Well, greatest common factor helps us a lot in math. So if we're able to find the greatest common factor, it's really helpful. So the first 2 numbers that we're going to find the greatest common factor for, you should have already organized your note sheet according to the picture that I showed you. We're going to find the greatest common factor for 24 and 40. So in your workbox, write 24 and 40 like this. We're going to list the factors. Now use your divisibility rules. That's why we just spent the time reviewing them. Always start when you're listing the factors with 1. Okay? 1 is a factor of every number. So 1 times what gives me 24? 1 times 24. So I'm going to list the factors like that. Then go to the next one. What comes after 1? 2. Anything times 2? Well, yes, 24 is an even number. So what times 2 gives you 24? 12. Anything times 3? Yes, if you go 2 plus 4, add up the digits, that's 6. 6 is a multiple of 3. We know 3 goes into 6. 3 times 8. Anything times 4? Yeah, the last 2 digits, right? There are only 2 digits here. Create a multiple of 4. 24 is a multiple of 4. 4 times 6. Anything times 5? Nope, it doesn't end in a 0 or a 5. Anything times 6? Repeat, I'm done. Let's go over to 40. The factors of 40 always start with 1 and then the number. So 1 times 40. Anything times 2? Yes. It ends with an even digit, therefore it's an even number. 2 goes into it. 2 and 20. Anything times 3? If I add up the digits, 4 plus 0 is 4. 4 is not a multiple of 3. 3 doesn't go into 4 and give you a whole number. So no. Anything times 4? Yeah, 4 times 10, anything times 5. Yes, because it ends with a 0. So 5 times 8. Anything times 6? Nope, I only see 2 on here. In order to be divisible by 6, both 2 and 3 have to be on my factor list. Anything times 7? Nope. Anything times 8? Yep, repeat, I'm done. So then, if you need to, you could list out the factors in order here. So for 24, I have 1, 2, 3, 4, 6, 8, 12, 24. These are all the factors of 24. The factors of 40, I could list it 1, 2, 4, 5, 8, 10, 20, 40. You don't have to list it out like this. If you can go through and determine which is the largest factor that they share, that's just fine. They share a 1, they share a 2, they share a 4, they share an 8. No. It looks like the greatest common factor would be 8. So the GCF, over in your GCF column, greatest common factor, that's what that acronym stands for, you would write 8. So one way to find the greatest common factor is to list the factors, and using our divisibility rules is really helpful to figure out if a number is a factor of another. Now, another way that we looked at this was in 6th grade, right? You don't have to use this way, but I just want to draw on your memory a little bit. So another way that we did GCF was using prime factorization. Tree, where you're taking a number and you're breaking it down into just its prime factors. If you like that, go ahead and use it. So if I have 24 and 40, what 2 factors, when multiplied together, give me 24? I can do 2 and 12. 2 is prime, it only has 2 factors, 1 in itself. So I'm going to circle it. Do you remember this? 12, I can break that up into 2 times 6. 2 is prime. 6, I can break that up into 2 times 3. Writing out the PF, the prime factorization from smallest to largest, 2 times 2 times 2 times 3. 40, I can break that up into 4 times 10. 4, I can break that up into 2 times 2. 10, I can break that up into 2 times 5. So my PF here would be 2 times 2 times 2 times 5. What factors do they share? Do you remember when we drew our Venn diagrams? They share a 2. They share another 2. They share another 2. I'm left with a 3 for 24. I'm left with a 5 over here. Right here is your GCF. Take and multiply your common prime factors. 2 times 2 times 2 is 8. And we got 8 as the GCF. Let's do one more GCF problem. You pick. You can list the factors, or if you remember how to use prime factorization, go ahead and use it. Your next 2 problems are you need to find the greatest common factor of 96 and 64. Pause the video, do your work, and come back and check your answer with mine. All right, so when I listed the factors, I got the GCF of 96 and 64 to be 32. When I took 96 and 64 and used prime factorization, so I broke it down into just prime numbers, the product of primes, I used a Venn diagram to tell me what primes they had in common. They shared a 2, they shared another 2, they shared another 2, they shared another 2, they shared 5 2s as prime factors. When I multiply 2 times 2 times 2 times 2 times 2, I get 32. So you pick. You can list the factors, you can use prime factorization, what are you comfortable with? But the whole idea is that you're also applying those divisibility rules that you use to help you make calculations happen a little faster.